In the previous examples, you've seen how we can determine the empirical formula of a compound if we can reduce the count-to-count ratio of atoms or the mole-to-mole ratio of atoms to the simplest possible whole number ratio. Well, typically when you do experiments in the lab, okay, then data that you have would be in grams. Okay, so whatever information you have in grams, you'll have to change it to moles. Okay, so here's an example that illustrates that. Let's say you have a compound, and you found out that that compound is made up of carbon, potassium, chlorine, and oxygen. And it's 31.9% potassium and 28.9% chlorine. This percentage are generally given by mass. Okay, so if it's 31.9% potassium, 28.9% chlorine, what's the percentage of oxygen? All percentages should add up. So 100 minus 31.9 plus 28.9%. That's 100%, right? So that would be, let's see, 100 minus 31.9 minus 28.9, it's 39.2% oxygen. Okay, that means any sample of this compound would have these percentages. So to make things easy for us, let's assume you have 100 grams. It doesn't really matter how many grams you assume. Let's say you have 100 grams of sample. Okay, based on that, we can say then that sample contains it's going to contain 31.9 grams of potassium. Okay, if potassium is 31.9%, then it's going to be 31.9 grams in 100 grams. It's going to have 28.9 grams of chlorine. Okay, the percentage of chlorine is 28.9%, and it's going to have 39.2 grams of oxygen. Okay, 39.2 grams of oxygen. Okay, so how are we going to determine the empirical formula based on this information? Okay, so let's rewrite that here. Potassium is to chlorine is to oxygen. It's in the mass ratio in grams. You have 31.9 is to 28.9 is to 39.2. Now you might be tempted to reduce these numbers to small whole numbers by just dividing by the smallest of these. Now that's not going to work because these are still in grams. Remember, if you want to know the empirical formula, you have to have the information in moles, mole to or counts. Okay, so mole to mole to mole. That's the ratio that you have to reduce to the smallest possible whole numbers. So we need to convert each one of these into moles first. So let's convert 31.9 grams of potassium into moles. So all you have to do, let's look up the molar masses. So molar mass, potassium. Okay, if you look at your, or if you can check your periodic table, it's going to be 39.098. So 39.10. Okay. So times 1 mole over 39.10 grams. So that's the molar mass, 39.10 grams per mole potassium. And so that gives me 31.9 divided by 39.1, 0.8159. Okay. Now notice here I have 3 significant digits. I should have 3 significant digits here. So number 5 here is my last significant digit. I'm just keeping that extra digit there just so I don't build up round-off error. So the mole-to-mole ratio. Okay, so for moles, this 31.9 is 0.8159. Okay. And your chlorine, molar mass of chlorine is 35.45 grams per mole. You can get that from your periodic table as well. So times 1 mole over 35.45 grams of chlorine. Okay, and that gives you 28.9 divided by 35.45, 0.8152. Okay, and again 3 sig figs, so 5 there is my last significant digit. There's 1, 2, 3 significant digits, 1, 2, 3. Okay, and finally oxygen. Right now you should have memorized the molar mass of oxygen. It's 16.00 grams per mole, so times 1 mole of oxygen divided by 16.00 grams of oxygen. Okay, and that cancels out grams, so 39.2 divided by 16, that gives you 2.45. Okay, so the mole to mole to mole ratio is 0.8159 is to 0.8152 is to 2.45. So now that we have the mole to mole to mole ratio, we can reduce that to the smallest possible whole numbers by dividing with the smallest of these, which is 0.8152. Okay, so 0.8159 divided by 0.8152 is 1.001. 3 sig figs, so that's practically just 1, right? And 0.8152 divided by 0.8152 is also 1.00, 3 sig figs. And 2.45 divided by 0.8152 is 3.005. Okay, 3 sig figs, so this rounds off to 3.01. So you have 1 is to 1 is to 3. 3.01 is very close to a whole number. So the potassium to chlorine to oxygen ratio is 1 is to 1 is to 3. Okay, so the empirical formula has 1 potassium, 1 chlorine, and 3 oxygen. So the empirical formula of this compound is KClO3.